As with any factoring, we always look for a GCF first. And if you go through this, you see that there is no common factor that goes into 4, and negative 63. So in that case, we have a trinomial. So I would normally say, okay, let's try AM. However, if you look at this, you can see that the lead coefficient is a 4. So in that case, then what we're going to do is we're going to do our little rainbow. So remember that we're going to just multiply 4 times that negative 63, and that's going to give us our M, which is negative 252. And we want to figure out what multiplies to negative 252 and adds to positive 4. Now, don't forget that in your calculator, you can go to your y equals and do negative 252 divided by x and go through the table, and it'll help you come up with numbers that you probably wouldn't come up with in your head. So what I have here, what multiplies to negative 252 and would add to a positive 4 is a negative 14 and a positive 18. So remember, we bring down the first term, which is 4x squared. Then in any order, we can write these two numbers. So negative 14x plus 18x, and then we bring down the last term, minus 63. So if you look at what I just wrote here in green, you can see that this really is equivalent to the original problem, which is here in blue. The only difference is this negative 14x plus that 18x, when we add that, will give us 4x. So we just kind of expanded that 4x, if you want to think about it that way. All right, so now, remember, we're going to factor by grouping. So we're going to group the first two together, and we're going to group the second two together, and we're going to come up with a GCF for each group. So for the first group, I see that there's a 2 and an x that they both have in common. So I'm going to factor that out, and I'm going to get 2x minus 7. All right, now when I look at the second group, I see 18x and minus 63. So I see that that has a GCF of 9. And if I factor that out, I will get 2x minus 7. Very convenient, because remember, we want what's in parentheses here to be the same as what's in parentheses here. Okay? All right, so we take the numbers that are on the outside, which is the 2x and the positive 9, put those together in a set of parentheses, and then we represent the 2x minus 7 once, and there we go. There's your answer. All right, so for number 2, again like in number 1, we're going to see if there's a GCF. And when I look through there, I have a common factor of 3, and I also have a common factor of a. So let's start by taking that out. So when I do that, I get 2a squared plus 5a minus 7. All right, so after I take a GCF out, if I see that I have a trinomial, but look here, my lead coefficient excuse me, is not a 1, so I need to do rainbow again. So I'm going to figure out what multiplies to negative 14, but will also add to 5. Okay? So when I do that, I see that that's a positive 7 and a negative 2. All right, so let's keep bringing that GCF down, that 3a. Now, remember when we factor a trinomial by rainbow, we bring down the first term. I'm going to shoot over to here. I'm going to look at these numbers here, and I want them to add to a positive 5, but I, of course, need that a with it. So I'm going to write plus 7a and minus 2a. Doesn't matter what order you put those in. I could have said minus 2a and a positive 7a. Doesn't matter. And then we bring down the last term. Okay, then we're going to group, and we're going to group. Alrighty, let's keep bringing that 3a down. All right, so out of the first two there, I see that they both have an a in common. So that leaves me with 2a plus 7. And out of my second group here, I see that they're divisible by a -1. And when I do that, I'm also going to get 2a plus 7, which remember, that's what I want. I want those parentheses to match up. All right, so again, I keep bringing that GCF of 3a down. All right, so now I'm going to take the numbers that are on the outside here, okay, and they get written together in one set of parentheses. And then I'm going to take the common terms, which is the 2a plus 7, and they get written in one set of parentheses. And there you go. Okay, so let's look at number 3. I kind of don't like this one because it's not in descending order of the powers. So in other words, my highest power isn't first. So I'm going to take a moment and let's just rearrange that. So the k to the 6th, that's the highest power, so I'm going to put that first. Then the next highest power would be the 8k to the 4th. And then lastly would be the 48k squared. All right, so once you've gotten them in descending order of the powers, let's look at a GCF. I also, just me personally, you do not need to do this, but it makes your life a whole lot easier. I don't like the highest power having that negative there. So when I look for a GCF, I'm going to take a negative out of that because I want that to be positive. So I'm going to take out a -k squared. All right, so I'm going to divide everything by a negative. Keep that in mind. So that's going to give me k to the 4th minus 8k squared. And then that is going to give me minus 48. Okay? All right, now when I look at this trinomial that I have here, I see my lead coefficient is a 1, so I don't have to do the rainbow. So I simply can just figure out what adds to -8 and multiplies to -48. Okay, so that would give me a -12 and a +4. So I'm going to bring down the GCF that I originally factored out. Don't forget that. And then I have k to the 4th here, so that's going to be k squared minus 12. And then in the next parentheses, I'm going to have k squared plus 4. Now you do want to ask yourself here, am I done? So really the only thing that you really can do, there's no GCF in either of these parentheses. However, look that I have a square. So you want to maybe say, are these a difference of two perfect squares? Well, k squared is a perfect square, but 12 is not. So we're done. And over here, these are both perfect squares. However, that's a plus sign. It's not the difference of two perfect squares, it's the sum. So we are done. So for number 4, I would try to find a GCF, but there is not a GCF with 64 and 27. And I do notice, however, that I have perfect cubes. So I'm going to go about just taking the cube root of 64m cubed, which would be 4m. And I'm going to take the cube root of 27, which would be a 3. All right, so let's just kind of revisit the formula that we're going to use. So the formula that we're going to use is going to be x minus y, and then x squared. Now, since we have a minus sign here, we're going to actually, remember, in the second set of parentheses, we're going to change that. So that'll be plus xy. And then we're going to have a plus y squared. That's just the general formula. Okay, so in this case, really, this is representing your x, the 4m, and your 3 is representing the y. Okay, so let's just go ahead and do this. So we're going to get 4m minus 3. All right, now, when we have x squared, that means we're going to look at that first term, which is the 4m, and we're going to square that entire quantity. So when we square that entire quantity, remember the 4 is getting squared, which makes 16, and the m is getting squared, which makes m squared. okay, plus xy. So xy means the 4m times the 3. So that would give me 12m plus, and then y squared. Now y is this last term right here, and we're going to square that. So that's going to be 9. There we go. All right, so we have a binomial. Still always going to check for GCF. And I know that 4 goes into both of those, so let me take that 4 out. And I'm going to end up with 25 minus 64x squared. And then I can see that that's dots. Those are perfect squares. So let me always bring down that GCF. And I'm going to write 5 minus 8x and 5 plus 8x. And remember, when you're doing this, it does not matter what order these two parentheses are in. You can switch those around, but you need a 5 minus 8x somewhere and a 5 plus 8x somewhere. Okay, now this is a question that we do not need to freak out over. Just because there's a fraction, it's not a big deal. We do have a binomial. There's a minus sign in between, and if you look at this, 81 is a perfect square. 49 is a perfect square. These exponents are perfect squares because they're even, remember that. So it's going to be dots, and we're just going to take a deep breath and don't panic over that fraction. So we take the square root of 81, which is going to be 9, and we're simply going to put it over the square root of 49, which is 7. Ta-da! See? No big deal. 1 plus 1 minus. Okay, now remember, when you have exponents, they're perfect squares if they're even, and the way you take the square root of them is just to cut them in half. So half of 16 is 8, and half of 4 is 2. And let's do that to the other one as well. Okay, and there you go, done. How about that? Alrighty, so let's look for a GCF, but remember what I said on that last one. I think that was number 3. You want to put this in descending order of the powers. So I'm going to put the highest power first, which is negative 3x to the 5th. Then I'm going to put the 30x cubed. And lastly, I'm going to put that 72x, minus 72x there. All right, now let's take out a GCF. Again, I really don't like to have this lead coefficient be negative, so I'm going to factor out a negative when I do this. So that will give me negative 3x that I can factor out as a GCF, and then I will get x to the 4th minus 10x squared plus 24. All right, now, if you look at this, the lead coefficient is 1, so all we need to do is AM. So we want to figure out what adds to negative 10 and multiplies to a positive 24. Okay, so that's going to give us a negative 6 and a negative 4. All right, so let's bring down the GCF that we originally factored out. Open up 2 sets of parentheses. We're going to have x squared in the beginning of both of them. And in any order, it doesn't matter. We're going to have a minus 6 and a minus 4. All right, now let's double check like we did on the last one. If you remember from number 3, we want to look at this and we want to see if it's the difference of 2 perfect squares. And it's not, because 6 is not a perfect square. However, if we look over here on the right, we do see that is the difference of 2 perfect squares. So we're not done. Let's bring down that GCF we originally factored out, and the x squared minus 6, and then we can do dots, and we'll get x plus 2 and x minus 2. All right, there we go. Alrighty, so we have a trinomial. Again, let's always start by looking for a GCF, which we don't have. And we also have a lead coefficient that's not a 1. So remember, we are going to rainbow to get our m. So we are going to figure out what multiplies to 60 and adds to 19. So that will be 15 and 4. All right, so we bring down the first term. In any order, that 15 and 4, it does not matter what order you put it in. I'm going to put a positive 15m and a positive 4m. And the reason, again, if you look at that, 15m and 4m, if you add those two together, that gives you this 19m. Okay, so that's where that's coming from. And then we bring down that 10. Alrighty, so let's group and group. So let's take out, what do you think? Let's take out 3m, and we'll end up with 2m plus 5. And on the second one, let's take out a 2, and we'll end up with, thankfully, 2m plus 5. All right, so the factors on the outside get smushed together in one set of parentheses, and then the common term gets put in the other. Okay, well, the common theme again, let's look for a GCF. And I notice that I could take a 3 out of there. So let me take a 3 out. And I'm going to end up with 16 minus a to the 8th power. Now that's a binomial. And let's look. This is a perfect square. We've got the minus sign. And the 8 is a perfect square. Because remember, if it's an exponent, as long as it's even, that makes that a perfect square. So I know that I can do dots. So let's open up two sets of parentheses. The square root of 16 is 4. 1 plus and 1 minus, it doesn't matter what order they're in. And remember, if you want to figure out the square root of a to the 8th, if the exponent is even, we just cut that in half. So half of 8 is 4, and this is 4. All right, now let's think for a second here. Are we done? Let's look at this. This is not the difference of two perfect squares because we have a plus sign. However, let's look over here. 4 is a perfect square. We do have a minus sign. And our exponent is even, which makes that a perfect square. So this binomial here can get broken down a little bit more. So let's bring down that 3. We don't have the difference of two perfect squares here, so we're going to bring that down. All right, and we're going to go one more step here, we think. All right, so square root of 4 is 2. Again, if it's dots, 1 plus 1 minus in any order. And then a to the 4th, we're going to cut that 4 in half. There we go. All right, let's just do one last check. We know this isn't the difference of two perfect squares, nor is this because we have a plus sign here. And the 2 is not a perfect square. And over here, the 2 is not a perfect square. So we're done. Okay, so that is your answer for number 9. So if we look, there is no GCF for 27 and 125. However, I look at this and I say, well, I can take the cube root of 27, and I know the cube root of 27 is 3. And the cube root of x to the 6th is x squared. Remember, all we're doing is dividing the exponent by 3. And the cube root of 125 is 5. So that is going to be your rule for, in this case, the sum of cubes. All right, so let's go over that rule. So that's x plus y, and then it's x squared. Now, remember, this is a plus sign. So when we're doing the second set of parentheses, the rule will be the opposite. So that would be minus xy, and then plus y squared. Okay, so we're going to look at this and we're going to say, well, this is kind of representing that x value over here in the equation, and this is representing that y value. Okay, all right, so I'm going to have 3x squared plus 5, and then in the second set of parentheses, when I have x squared here, what that means is the first term squared. Well, here's my first term, and I need to square it, but remember, I need to square the 3, and I need to square the x squared. So when I square the 3, I get 9, and when I square x squared, I get x to the 4th, minus, all right, x times y. So that's your first term here, times your second term there. So that's going to be 15x squared. And then the last term is y squared. Okay, so the last term in this set of parentheses is y squared. This 5 here represents y, and we're going to square that value, which would be 25. Here's your answer. All right, so this question is a little bit different. It's asking, or it's giving you rather, the area of the rectangle is represented by this expression, and they want the dimensions. Well, if you remember, the area of a rectangle is the length times the width. So what we're trying to do is we're trying to take this trinomial and break it down into two factors that multiply. So in other words, if we try to factor this, we will be able to find what our length is and what our width is. So if I look at this, I see it's a trinomial. There's no GCF, and the lead coefficient is a 2. So I know I'm going to have to do AM. So my M is going to be, what is that, 30, right? So I want to multiply to 30 and add to 13. So let's bring down the first term, which is 2x squared. And what multiplies to 30 and adds to 13 would be 10. And then plus 3x. So let's just take a minute here. So this 10x and this 3x together give you this 13x. Okay? And then we bring down the last term, which is plus 15. All right, so let's group the first two terms and group the second two terms. So out of the first two terms there, I can take out a 2 and an x, which is going to leave me with x plus 5. And out of the second two terms there, I can factor out a 3, and that's also going to leave me with x plus 5. All right, so I'm going to take the 2x and the 3, bring those together in one set of parentheses, and then the common term goes in another. All right, so let's just read the question again. So all it says is to represent the dimensions in terms of x. In other words, when it says in terms of x, that means you're going to have x in your answer. So your dimensions for your rectangle are 2x plus 3 and x plus 5. And because we don't know which one is the length and which one is the width, we don't assign like 2x plus 3. We don't say, okay, that's the length and the x plus 5 is the width. We're really not sure. So we just simply say that the dimensions are 2x plus 3 and x plus 5. So 12 is somewhat similar to number 11, but there's a slight change because this is asking for the perimeter. We'll address that in a second. So let's just look at the area of the rectangle. They give you this expression that represents the area. Let's start by thinking about, well, if I could find the length and the width, right? If I have a rectangle and I know what the two lengths are and I know what the two widths are, can I add up those four sides and I would get the perimeter? So, if that's the case, what I need to start with is figuring out the length and the width. So we're going to do exactly what we started with in number 11. So we're going to try to figure out, in this case, what's going to multiply to 36 and would add to negative 13. And that way we can do our little rainbow factoring and we can get the length and the width and go from there. All right, so we're going to bring down the first term, which is 6x squared. So what multiplies to 36 and would add to negative 13? So that would be a negative 9x and a negative 4x. So when I add these two numbers, I'm going to get negative 13x, and if I multiply them, I would get a positive 36. Okay, and let's bring down that last term. All right, group, and let's find a common factor. So I see a 3x in the first two terms, and let's divide that, and I'm going to get 2x minus 3. And then in the second term, the second group there, I see a negative 2, and that's going to give me 2x minus 3. All right, so 3x minus 2 is one of the dimensions. We're not sure whether it's the length or the width, but it doesn't really matter. and then the other dimension is going to be 2x minus 3. Now, remember, they're not asking for the dimensions, they're asking for the perimeter. So if the 3x minus 2 represents either the length or the width, it doesn't matter, and 2x minus 3 represents the other one, if we want to find the perimeter, what we're going to do is essentially we're going to add the 3x minus 2 and 3x minus 2, right, because there's two lengths, okay, or they could be two widths, we're not really sure, it doesn't matter, and then 2x minus 3 and the other 2x minus 3, right, because a rectangle has four sides. One group of two should be the same, and then the other group will be the same. So to find the perimeter, all we're going to do is add those up. So let's add up all the x's. So we have 3x, 3x, 2x, and 2x. So that's going to be 6x plus 4x, which is going to give us 10x. And then all we're going to do is we're going to add up the numbers here at the end. So negative 2, negative 2, negative 3, and negative 3. And that will be minus 10. And that expression represents the perimeter. In terms of x means you'll have x in your answer. Alrighty, so number 13, we are starting here with an expression that represents the volume of a rectangular prism. Now, let's remember what the formula for volume is. Volume of a rectangular prism is the length times the width times the height, right? So we're going to do kind of what we just did in 11 and 12. The only difference is instead of getting two factors, we should end up getting three. Let's look at this. We actually have an expression with four terms in it. So usually when we do it when we have four terms rather, remember we group the first two terms and we group the second two terms. Okay, now let me just back up for a second. I should say that I would always look for a GCF first, but yet when I look through, the four terms do not have any common factor. All right, so let's look at the first two and say, well, what can we take out of there? So we can take out 9x squared, and that will leave us with x plus 7. And then in the second term, I can take out a negative, in the second group rather, I can take out a negative 1, and I'm left with x plus 7. All right, so I have 9x squared minus 1 and x plus 7. So then you say to yourself, now wait a minute, I only have 1, 2 factors, and I'm supposed to have 1, 2, 3. So hopefully at this point your brain's working, and you realize, oh, this is the difference of two perfect squares. So I can keep going with that. So let's open up two sets of parentheses on that, and we're going to get 3x plus 1, and we're going to get 3x minus 1. And then we drop down x plus 7. Now we match up 1, 2, 3, 1, 2, 3. Perfect. All right, so when they're asking, when they're asking for the dimensions, you would say the dimensions, and again, don't assign one of them to be the length and one of them to be the width and one of them to be the height. Just say the dimensions are 3x plus 1, 3x minus 1, and x plus 7. And those are the dimensions of that rectangular prism. All right, so now let's take a look at this one. This is like one of the other questions that we had done in our factoring packet. And it's a little bit tricky, but once you see the trick, then it ends up not being so bad. If you notice, inside the parentheses, I have the same exact thing. So if you remember from the factoring packet, what we did is we took that binomial and we assigned it a different letter, like an A, let's just say. So I would say that A, I'm going to represent that by 3x squared plus 4x. Okay, so let me just stop for a second. One of the reasons why I'm doing that is if you look at this entire expression, it is a trinomial. It has 1, 2, 3 terms. But there's not a GCF. And you know, I'm looking at this expression and I'm saying to myself, how would I even begin to factor that? You could say to yourself, well, hold on, maybe it has something to do with adding to negative 11 and multiplying to 28, and you would be getting warm if we were playing hot and cold. So what we're going to do is we're going to kind of take off from that general thought, and we're going to assign what's inside these parentheses a simple value of a, and let me explain why, just in case you forgot. So now, instead of writing this big mess, I'm going to write a squared. Okay, now let me explain again. This represents a, right? That's right over here. And this squared term right here is this squared term right up there. Just dropped it down. Got it? Okay. Then minus 11, and here we go again. This binomial here, we are representing by a. So all I'm going to do is tack on an a there. That's where it's coming from. See it? Okay. And then I have plus 28. See, now if you look at this, this expression is a lot easier to factor than this whole huge disgusting mess right here. Okay, so it's a temporary substitution, so to speak. All right, so let's just kind of go with this for a second. So we're going to figure out what adds to negative 11 and multiplies to a positive 28, right? So that would give me a minus 7 and a minus 4, right? Okay, now we would think, yay, we're done. But if you read the directions, it says a product to represent it as a product of 4 linear factors. So I'm kind of missing some stuff here. Now remember, if we look over to the right, we have a value for a. So now what we're going to do is we substituted this mess here. We replaced it with a to simplify this trinomial to make it easier to factor. Now what we need to do is we need to take what a's value is and substitute it back in here and here. Okay, so watch. So we're going to take that and we're going to write 3x squared plus 4x minus 7. All right, so look, a is 3x squared plus 4x, and that minus 7 drops down. Okay, I'm going to do the same thing with the next set of parentheses. I have an a, so I'm going to replace that back with 3x squared plus 4x and drop down the minus 4. So let me kind of point and show you again. So this a here is represented by 3x squared plus 4x. Remember, that's what we got over here. And this minus 4 right here is right there. Okay? All right. Now, what we're going to do is we're going to have oh so much fun, and we're going to rainbow. And we are going to rainbow twice. So we're going to rainbow here, and we're going to rainbow there as well. Okay? So let's look at the left. We want to figure out what adds to 4, and I'm going to try to squeeze this in, I'm sorry, multiplies to negative 21. Okay. All right, so let's bring down the first term, that's 3x squared, and then I'm going to get plus 7x and minus 3x, and then bring down that minus 7. Okay. All right, let's look at the second set of parentheses. I'm figuring out what adds to 4 and multiplies to negative 12. So, bring down the first term, and that's going to give me a positive 6x and a minus 2x, and then I'm going to bring down that negative 4. All right, I'm going to group the first two terms, group the second two terms. I'm going to do the same thing over here and the same thing over here. All right, so we're going to be taking out an x, and I will get 3x plus 7. Here I'm going to take out a negative 1, and I will get 3x plus 7. That's a good thing, right? All right, let me just take a moment and let's put this in its own set of brackets there. Okay, so we don't get it mixed up between the second set here. All right, so now let's look at the second set. So if I look over here, I'm looking over at this expression in the second set of parentheses. Okay, I'm going to figure out what do they have in common. Well, I see a 3x, and then, oops, hold on. Gotta love those solicitors. All right, so that's going to give us x plus 2. And then if I look at the second group, I see I have a negative 2. And that's going to give me also x plus 2. Okay, and then let's just close those brackets right there. There we go. All right, I know this is a mess. Here we go. So I'm going to have x minus 1, and I'm going to have 3x plus 7. Then over here on the right, I'm going to have 3x minus 2, and I'm going to have x plus 2. And voila! It is a product of 4 linear factors. Check it out. 1, 2, 3, 4. So this is your answer then, as the product of 4 linear factors. 1, 2, 3, 4. All right, everybody takes different approaches to answering something like number 15. I personally think one of the easiest approaches is if you look, for example, at choice A or B. Just for example, if you look at the right side of the equal sign, maybe one of the easiest things to do is to triple distribute and then see if what you get is equivalent to what you have on the left side of the equal sign. Okay, now the answer for 15, let me just go right out there, oops, is going to be choice C. And let me explain why that is. So if you look at C, it's 8a to the 6th plus 27. All right, well that's the difference of cubes, or in this case, the sum of cubes. All right, so what I'm going to do is I'm going to take the cube root of each of these. So the cube root of 8 is 2, and the cube root of a to the 6th, just divide by 3, is a squared. All righty, the cube root of 27 is 3. So if you recall the formula, and the formula is, we can use x's and y's, we can use a's and b's, it doesn't really matter. X plus y in this case, because I have a sum. And then it's going to be x squared minus xy, and then plus y squared. That's the general formula. All right, x representing the first term, and y representing the second term. So the 2a squared would be the first term, and the 3 would be the second term. So if I wanted to factor this, then I would take the first term, and I would add to it the second term, and then I would take the first term, which remember is the 2a squared, and I'm going to square that entire quantity. So square 2, I get 4, and that would be a to the 4th minus 6a squared, because remember, x times y is the first term here, times the second term there, okay, plus y squared, which is your last term, which is that 3, which would be 9. Okay, now if you look at that answer and compare it to choice C in the second set of parentheses, that's a plus 6a squared, and it is supposed to be a minus. Okay, that's why your answer is choice C. Okay, last but not least. So what we have here is representing the area, and they want to know which of the following correctly expresses the product of the dimensions. Well, that's very similar to what we saw in number 11 and 12, and even actually number 13. So we're going to go ahead and we're going to factor. All right, well, we do have a Lie coefficient that's 1, so no need to do the rainbow. And there's also no GCF, so I really should have started with that. So I'm just going to figure out what adds to negative 18 and multiplies to 81, which in this case would be a negative 9 and a negative 9. Alrighty, so two sets of parentheses, x squared's going in both of them, and minus 9 and minus 9. Okay, now let's check that out because I see dots in both, obviously, right, because they're the same. So x plus 3, x minus 3 for the left set of parentheses, and we're going to repeat this again, x plus 3 and x minus 3. All right, so let's just read the question here. Which of the following correctly expresses the product of the dimensions of the square? Okay, now if you look at the four choices, what I have right here is not there. However, if you notice, I've got some repeats here. I have an x plus 3 and another x plus 3. So remember, when I have one quantity, in this case, twice, I can represent it as that quantity squared. Okay. Likewise, I have x minus 3, and I have x minus 3, and I, in this case, have that also twice. So I can always represent that quantity itself squared. So this would help represent the dimensions of the square, and that is choice A.